So today we are talking about caches. So how caches are used in open source search engine like Apache Solr. And more in details, today we will see what is a cache, just a brief overview. Then we will see what are the caches used in Solr. We actually will focus on a couple of caches. With a brief introduction to a useful tool that is the cache view handler, but I don't want to spoil too much now. Let's see later on. And finally, I want to, so with practical example, we submit some practical queries to Solr, and we will see how caches behaves to process these queries. So let's get started. First of all, what is a cache? A cache is a hardware or software component that stores previous client's request into a fast memory in order to speed up. So, okay, let me read. So future requests can be served faster. So from this definition, we can identify three different actors. We have the cache, we have a client that submits some request, and we have a data provider. The cache is a kind of key value database because the key that identifies the request and the value is the data provided by, I call it, data provider. We can see this architecture at different layers of the IT system. For example, at low level, we have the client can be the CPU and the data provider is the RAM, for example. Indeed, in the middle, there is L1, L2 cache, or otherwise we can see the same architecture on high level. I don't know, for example, the client can be your browser, the data provider is a web server, and the cache is implemented, I don't know, storing some web page on your local file system. So in a search engine, in our case, Solr, we have the data provider that is Apache Lucene, that is that Solr actually embeds Lucene, and the client is still the client actually. So we now see what are the caches implemented in Solr to speed up the queries. Actually, today we have 30 minutes. We will focus on the query result cache and filter cache. The query result cache is the first cache involved in a search. It stores is the more high-level cache, and it stores the list of a list of document IDs. Actually, they are the Lucene IDs. This list is ordered and is identified by 4 parameters provided by the client. We have the query, the filter query. So, I mean, the query is what the client is looking for. The filter query is a clause that is a condition actually that allows us to filter some documents. The sort, okay, I don't think it needs more explanation. Min exact count is another parameter that allows Solr. You're telling Solr, okay, stop the execution, stop processing the query as soon as you find, I don't know, 10, 11, 100 documents. This means that Solr may also apply some approximate algorithm in order to speed up the query. So, but this one produce a list. So it makes sense to use this min exact count only if you want your results ordered by score in descending order. So if you also put the sort clause, probably Solr does not use any advantage for the min exact count, but you risk to increase the possibility to miss to don't find any value in the cache. I mean, I want some data ordered by name, just something random. I put the min-x account from a value provided by a customer, externally. So I don't have any advantage of using this min-x account, but I also can have some not problem, but I can reduce the possibility to hit the cache. Let's see randomly. Oh, what's going on? Okay, so this is just a few examples. We have a query. I want to see. I forgot actually to write in the slide, but we are in a collection, in a film collection. I want to get all the films that contains band in the name. I don't want drama films, and I want all the results sorted by name. Okay, as you can expect, you can see all the 4 parameters in an object that goes to compose the key. Actually, the min-x account in this example is not present, so by default, Solar put the maximum number we have available in Java. This is another example. Just we are using a thismax query. In this case, the query is translate in a losing query, and the only difference we can see compared to the previous example is that the query is not just the queue parameter, the queue clause, but contains something more complex. Okay, in this example, we want to have drama movies. Okay, then we want to get will and band present in one of the fields, author and name. So the query becomes something like, actually not something like, but it becomes author must contain will, or name must contain will, and author must contain band, or name must contain band. This is just a transformation of the original query. Let's see what we do with the filter cache. Actually, the filter cache is more low level. It doesn't compare to the previous one. Actually, it still store a list of documents, but this is the result of a subquery. Actually, this is just the result of the condition we express in the filter query. It also it uses a positive logic. So if, considering the example before, I don't want drama movies, in the filter cache, I will get the list of drama movies. So the query will be transformed. And actually, this is a bit of an edge case. If I set this parameter, so use filter for sorted query in the Solar config file, and the result set must not be sorted by score, the filter cache is also used to store the condition the documents that comes from the condition expressed in the queue clause. This is something now we will see some example, and we will see how this cache behaves. But before doing it, let me introduce this useful tool. Actually, this is a plugin that we can install on our Solar. It is quite recent. Actually, it's pretty recent because this has been introduced mid-December 2021, so a few months ago, actually. When you install it, this plugin creates a new endpoint under the root admin, and going there, it can show you all the data, actually all the keys and the number of data contained in the filter cache. So let's now move to something more practical, and let's start seeing one of the simplest query. Okay, just before I start, let's consider that in the Solar config file, the use filter for sorted query parameter is false. So in the next example, this is we are not expecting to store the subquery, so the document ID coming from the subquery, the Q query. So as we can expect, we can run. I want drama movies that contains band in the name, and I can simply store the list of drama movies in my filter cache. Now, what happened? If I change my mind, I don't want drama movies. As we can see, it is as we can see, yeah, we still Solar will still use the positive logic, so it still see the list of drama movies, but there is something weird. Why do we have wildcard column wildcard? So it means the full list of documents. It's because if Solar notice that all the filter query clauses are negative, in this case we have only one, so 100% of them, it transforms the query, the negative queries, in something in a composed condition of all documents minus the drama fields. And it executed these two clauses separately, and then we can find both keys in the filter cache. Now, restart Solar, setting the use filter for sorted query parameter. We ask Solar to sort all the results by name, and indeed we have both condition true that we said before, and as we can see, we also have the name band, actually the Q clause stored in the filter cache. There are 3 documents. If I remove this sort parameter, I don't see anymore the, okay, just I restarted Solar, so I clean up all the caches. But anyway, removing this sort clause, I don't see anymore the Q parameter. This is why by default, all documents are sorted in descending order by score. So actually, there was the condition we didn't want before. Let's now see something different, because in that time we always express the end condition. So I mean, if I add in my query 2 different filter query clauses, Solar compute them join them in an end, the logic end. But how about if we want an OR? What we can do is adding a single filter query clause, and we can join the 2 conditions with the OR. So Solar does all this computation, retrieve a list of document IDs, and stores all the result in the filter query. But now what I wanted? I wanted sport movies where they are directed by Russell. I don't know, I put a random name. So Solar compute the list for sport, compute the list of document ID for Russell, and create the union. How about, I'm talking about sport, now I want to see all the fields that contain Messi. So in this case, Solar compute all the list for sport one more time, the list for Messi, create the result, create the union, and put the result there in the filter cache. So I can see 2 different entries in this cache, but we didn't take advantage from the previous search. So what can we do? We can take advantage. We can use actually keyword filter. So filter allow us to, we are using filter, we are telling Solar, okay, everything is contained, all the conditions contained between the parentheses, you are forcing Solar to use the filter cache. So in the meantime, I restarted Solar, run this query. What can we see? We are storing the result. So we are computing the list of sport films, storing the result, computing the list of the films directed by Russell, storing the result, compute the union, and storing the results again. Now, I want to see all the movies that contains Messi in the name. When I'm computing this second query, I can find in the filter cache, I already find actually all the list of sport movies, and I don't need Solar. Actually, it doesn't need to compute this list one more time. So in this case, so the first time we want these sport films, we already find the result in the filter cache. We compute the list of films that contain Messi. We don't find anything because in the filter cache we found 0 documents. But anyway, we compute the union and we have a result. I think I've been faster than I was expected. Actually, this was my last example. In the meantime, we are writing and publishing a new blog post on our website. So with this kind of example, so more practical.